Hi everyone, today I am going to talk about the elimination of trigonometric ratio, which is a very important part of the trigonometry because this chapter is a very useful for the perspective of the board examination. Each and every year a single one question is mandatory to ask the board from this chapter. So now I am going to teach you how you have to approach this chapter and how can you solve any question belonging to this chapter, because this chapter is one of the very easiest among all the chapter of the trigonometry, and because you have not to use your extraordinary mind, just you have to done what is the calculation which you done from the earlier classes, and now something you have to use the concept of trigonometric identities or the proving concept, which you have to study the mainly the three formulas, which is the sin square theta plus cos square theta is equal to 1, like this. So now how will you solve? So in this question you have to proceed, learn first of all, then you will able to find out the answer. Now as you are able to see that we have the a square minus x square. So how can you find the a square minus x square from the given question? So we have to we have given with the x is equal to a sin theta. So now you have to find the a by x. So how can you find? So a by x can be find like this. When you transpose the sin theta here, it's become the 1 by sin theta, and it remains the 1, and x can be transposed here, so it become like this. So we have like this, and 1 by sin theta can be written as cosec theta, and so cosec theta is the a by x, and like this the cot theta is equal to the by. So like this, when you transpose this one, you will get like this. Now you have to just see that what the question required. The question required the squares in this, the value like the a by x. So just squaring both the side, you will get the cosec square of theta, which is equal to a square by x square, and here you will get the cot square of theta is equal to b square by y square. But here now you get that the a square by x square and the b square by y square, the values of both of them. Now you have to subtract the a square by x square, a square by x square by the b square by y square, which is equal to 1. You have to prove, and a square by 1 square, what? This is the cosec square of theta as we get, and the b square by y square can be written as cot square of theta, and this is you have to prove equal to 1. So as you know that the cosec square theta minus cot square theta is equal to 1, using the identities which you have studied in the chapter named trigonometric identities. So just you have to use the calculative mind, and now you get to the answer. Like this you have to done in all the questions related to this chapter. And now just solve the another question which is also like this. So this one we have solved already. Now we have this, the tan theta plus sine of theta, which is equal to m, and now the another thing is given that tan theta minus of sine theta, which is equal to n. Now you have to prove that m square minus n square is equal to 4 root m into n. Now just you have to put the values already, as you get the values of m. Now wanting here the m square, that means the tan theta plus sine theta, the square of this one, a square of this one. Now minus sign, then the values of n square. So n square is equal to tan theta minus of sine theta, but here wants the question wants the square, so right here the squares. Now you have the 4 into m into n. We have the tan theta plus of sine theta, and then n we have the tan theta minus of sine theta. Like this we have. Now how you have to solve? Just you have to open this, then you will get the tan square of theta plus sine square of theta, and sine square of theta plus 2 tan theta into sine theta, and here when you open this one, you will get the tan square of theta plus sine square of theta, and then 2 tan theta sine theta, like this. And when you will open this one, it is the a plus b into a minus b, which is the a square minus b square, which is the identity. So this can be written as the tan square of theta minus sine square of theta. So now you get to this conclusion. Now when you open, it is the tan square of theta plus sine square of theta plus 2 tan theta sin theta, and it become the tan square of theta plus sin square of, sorry, minus sin square of theta, because minus multiplies, and it become the 2 tan square of theta into sin square of theta. Tan theta into tan theta will be cancel out, sin theta cancel out, so it will be left with the 4 tan theta, and then sin theta, which is equal to, we have that tan theta, tan square of theta minus sin square of theta, but the both of them is doesn't looks or seems to be the equal, so you have to prove that both of them are equal. So 4 can be cancel out. Now we left with the tan theta into sin theta, but this side doesn't seems like this, so how will you find? So tan square of theta can be written as the sin square of theta by cos square of theta, and then sin square of theta like remain this one. So you will get the LCM cos square of theta, which is equal to sin square of theta minus of sin square of theta into cos square of theta. Now we are solving the RHS, as we have the LHS, the tan theta into sin theta. Now how will you solve this? All is in the under root. Now when you take the common here, the sin square of theta, in the sin square of theta, you will get the 1 minus cos square of theta in 1 minus cos square of theta, and then cos square of theta. Sin square of theta and sin square theta by cos square theta can be written as the tan square of theta, and 1 minus cos square theta can be written as sin square of theta. So now we have the tan square of theta into sin square of theta, and this can be written as the tan theta into sin theta, and this is what we have to prove this side. So I think you understand how we have to proceed. Just we have to done the calculation after understanding what you have to done or find in the question. So I think you get to know how we have to solve this question related to this chapter. And now very interesting or fantastic question we have of this chapter, that is the question number 3. If the cos theta plus sine of theta is equal to root 2 cos theta, then you have to show that the cos theta minus of sine square of theta is equal to root 2 sine theta, as we have to prove that the cos theta minus sine theta is equal to root 2 sine theta. So that means we have to prove, that means we don't know the value of this, so we don't know the value of this. So let's suppose this is equal to the x, this is equal to x. Now we have to prove that x should be equal to root 2 sine theta. So how will you prove? As you have to think, the trigonometry chapter is mainly related to the developing your thinking ability. So you have to think how can you solve this problem. So now as you have studied the three trigonometric identity, which is the sine square of theta plus cos square of theta is equal to 1, and the sec square of theta, cos tan square of theta plus 1 is equal to sec square of theta, 1 plus cot square of theta is equal to cosec square of theta. So if you able to observe that in all the three identities you are getting the squares in the trigonometric function. So if you are going to solve this one, then you have to make the squares in the function. So how can you make the squares, as we haven't any type of squares? So let's suppose this one is the first equation and this one is the second. So you have to make the squares. So how can you do? So you have to squaring both the side, because in the mathematics if you are the side, it is